we are to sketch the graph of functions, starting with the graph of a standard function and applying transformations. So when we see y equals the absolute value of x plus 4, we see that the x plus 4 is inside an absolute value. So the standard function is y equals the absolute value of x. The x plus 4 has been substituted for the x to become the inner function. This is going to move the standard function 4 units to the left. So if I graph the standard function, y equals the absolute value of x, it's going to go through 0, 0, let's say 1, 1, and let's say 2, or negative 2, 2. Now we're going to graph the absolute value of x plus 4 by moving each of these points 4 units to the left. So negative 2, 2 would be moved to negative 6, 2. 0, 0 will be moved to negative 4, 2. And 1, 1 will be moved 4 units to negative 3, 1. And so if we join the points, notice that negative 2, 2 is actually on the transformed function, because if I put negative 2 in for x, I get the absolute value of 2, which is 2. So we have another v-shape, but it is all of the x values have had 4 subtracted from them. In the second example, our standard function is y equals x squared. This time, the transformed function is y equals x squared plus 1. So notice that the x squared is intact. The plus 1 is added on the outside, which means we're going to go 1 up with our standard graph. So let's look at the curve, which is a parabola shape for the standard function y equals x squared. And let's let this be the point negative 2, 4, and 2, 4, as well as 0, 0. Now we're going to be going up 1 unit. So when we go up 1, and so these points are going to be 0, 1, 2, 5, and negative 2, 5. The shape is still a parabola. But it is moved up 1 unit relative to the original. So plus 1 for the y values. Our third example is actually a reflection. The third example is again based on y equals the absolute value of x, but we are to graph y equals the opposite of the absolute value of x, or -1 times the absolute value of x. So notice that the absolute value of x is intact in both. So we're going to have an effect on the y value. We're actually going to reflect the graph vertically over the x-axis. We're going to take the opposite of each of the y values. So starting with, here's y equals the absolute value of x, going through -1, 1, 1, 1, and 0, 0, we are going to be reflecting our points across the y-axis, across the x-axis. So we're going to go to the point 1, -1. This one is going to go to the point -1, -1. 0, 0 is not affected when we reflect because the opposite of 0 is 0. So our new graph is y equals the opposite of the absolute value of x, is a V shape but opening down instead of the standard function that opens up. And the last one is with a standard function which is not quite as familiar, y equals the cube root of x. And we're going to transform that to get y equals the cube root of the opposite of x. So since x has been replaced by the opposite of x, we're going to affect the x values. We're actually going to reflect the curve of y equals the cube root of x over the y-axis. So the graph of y equals the cube root of x goes through the origin. It also goes through 8, 2, and -8, -2. And the curve looks something like this. Now, when we reflect the points over the y-axis, the origin will stay where it is, but the other 2 points will have their x coordinates replaced by the opposite. So 8, 2 will go to -8, 2, and -8, -2 will go to 8, -2. So the curve will now be in the second and fourth quadrants instead of the first and third quadrants. So the blue curve is y equals the opposite of, equals the cube root of the opposite of x.